Hey everybody, so now we want to today graph a picture of a quadratic equation. Our quadratic equation is real simple. It's y equals negative x squared. So we know it's an equation, it has an equal sign. We know it's quadratic because it's degree 2. The easiest way to graph any equation in math is to set up a t-table of values. Now when you get to set up a t-table from scratch, you get to pick any numbers you want for x. Most of us would avoid picking decimals and picking fractions. We want to work with whole numbers or integers. So when I set up this t-table of value, that's what I'm going to pick, integers. You can pick whatever you want, but I'm consistent. You always need to pick a positive number. You always need to pick a negative number. You always need to pick 0. Unlike graphing a line where you only need 2 points to connect to draw a line, to graph a parabola, this letter U, you need a minimum of 3 points, if not more. So for this time to do a t-table, we're going to be able to pick 7 values. So just like on the slide, I'm going to pick negative 3, negative 2, negative 1, 0, 1, 2, 3. And what we're going to do is once we pick these x values, to get the y values, we don't make up numbers. We substitute these in one by one into your equation. Now I want you to notice in front of your equation is negative x squared. What's the coefficient there? That's right, it's negative 1. So here's the boo-boo you guys always make. You guys assume that we're going to take whatever number's here and multiply it to negative 1 first and then square it. But that's incorrect. That's not following, please excuse my dear Aunt Sally, order of operations. Remember, this square just belongs to the x, and we have to do exponents first. So when we're substituting into this equation, we're going to square our x first and then multiply it by a negative 1. So I'm just going to do the work here on the side. I'm going to write y equals negative 1 times negative 3 squared. You do not multiply first, you square first. If I take negative 3 and square it, I'll get a positive 9. So now this is y equals negative 1 times 9. A negative times a positive is a negative, so we get a negative 9. I'm going to do the same thing with negative 2. Y equals negative 1 times negative 2 squared. Negative 2 squared is 4. And now I have negative 1 times 4, which I know is negative 4. Third value, y equals negative 1 times negative 1 squared. I square first. Negative 1 squared is a positive. So this is y equals negative 1 times positive 1, which is negative 1. All right, 0. Y equals negative 1 times 0 squared. 0 times 0 is 0, and 0 times any number also happens to be 0. 0 factor property. Anytime you multiply by 0, your answer, your product is 0. Now I'm going to do 1. So this is y equals negative 1 times 1 squared. 1 squared is 1. Well, we've already done that. 1 times negative 1 would give me negative 1. Next value, y equals negative 1 times 2 squared. 2 squared is 4. Well, we've already done this. 4 times negative 1 is negative 4. Lastly, y equals negative 1 times 3 squared. 3 squared is 9. Well, we've already done this. 9 times negative 1 is negative 9. All right, everybody? So that's all that was substitution, but you have to know your order of operations. Now let's pull down our handy-dandy Cartesian plane and graph. Doesn't matter which ordered pair you plot first, but you have to understand every time you plot a point, it starts at the origin. So if I'm going to plot negative 3, negative 9, the negatives are given direction. Negative 3 means go to the left to negative 3, and negative 9 means go down to negative 9. And there's that point. Negative 2, negative 4. Go to the left to negative 2 and down to negative 4. Negative 1, negative 1. From the origin, go to the left to negative 1 and down to negative 1. 0, 0 is at the origin. 1, negative 1. Now your x value is positive. So we'll go to the right 1, down 1. 2, negative 4. From the origin, go to the right 2 because it's positive and down 4. 3, negative 9. Go to the right 3 and down to negative 9. So now you have 7 ordered pairs plotted. And if you connect those slowly and carefully, do not make a V, you have to make a curve. So I'll do the first half, I'll make the curve, and I'll do the second half. And just like lines, at the end you put arrows to signify that goes on forever. The same thing with parabolas. You put arrows to signify this would keep going down if we plotted more points. Because we only plotted 7 points. We could have continued this T-table and made it bigger. Okay, so that's your basics on graphing a simple parabola. See you in the next module.